All right, in this example, we're going to look at scientific notation, and I thought I would start by explaining what scientific notation is before we actually get into the maths involved. As the name implies, basically, we use scientific notation a lot in science because we're dealing with very large numbers, but also very small numbers. So I'm going to give you two examples, one of very big numbers and one of very small numbers. So as you can see on the screen, we're looking at the distance of planets from the sun. Now, I'm not going to go through every single one, and these distances I can see have been rounded already. Okay, so they've been rounded to the nearest million. But, if we weren't doing rounding, you could also use significant figures. But we're just going to look at scientific notation right now. I'm just going to look at this column here, the distance from the sun, and you might like to have a little bit of practice later doing the distance from the earth. The other two columns, so the number of years columns, we're not going to worry about just now. And as you can see, these are very big numbers. So Mercury being the closest sun, Earth to the closest planet to the sun is 58 million kilometers away. So imagine if we were a scientist and we were into planets, you wouldn't be writing these large numbers all the time. Okay, so that's where scientific notation comes in. We call these the basic numeral or the standard form of the number. And what we're going to do is convert it into scientific notation. So let's just take, Mercury as the very first example. So basically, we always write, where can I do it? We'll do it over here. So I'll just do M for Mercury. So we write the first number and then a decimal. Okay, so we've only basically got a single number and then a decimal place and then any number that comes after that. So we don't include recurring zeros. So you can see here that we've only got zeros left. If there are other numbers here, I would write those numbers unless I was rounding. Okay, so I'm only doing 5.8, and then it's times 10 to the power of something. Now, the power, you could say, all right, how many places has the decimal place moved? So basically your decimal, which we don't write, but it is here. Okay, how many spots has it moved? 1, 2, 3, 4, 5, 6, 7. So it's times 10 to the power of 7. And if you're ever unsure, you can check it on your calculator, but sometimes your calculator doesn't like big numbers either. So it will give you the scientific notation answer, which you, I guess, need to be able to interpret as well. All right, let's choose Earth just because that's where we live. Okay, so maybe in your head, think about what would Earth be, or even pause the video to see if you can write it. Okay, so our first number is 1, and then we have a decimal place, and any numbers after that which are not 0, so 5. As you can see with, I might do Venus next actually. I was going to explain Venus, but I might do Venus with you. Okay, so 1.5 times 10. So how many spots has it moved? Now I don't need to count because they're in groups of 3. So 3, 6, 7, 8. 1.5 times 10 to the power of 8. Now the reason I wanted to do Venus, and I skipped it before because I thought, oh, we're not going to do every single one, but Venus I notice has something different that no other number has. And I don't know whether you picked it up, but before I said you don't worry about the zeros, but we do worry about zeros if they're in between other numbers. So this one here I would write as 1.08. And I stop there. Okay, so it's just when you have your recurring zeros. Okay, how many spots has it moved? 3, 6, 7, 8. So it's the same as Earth. And if you look at the two numbers, they're the same number of figures in the number. All right, now Pluto, being a dwarf planet, very far away, we write 5 point. Okay, and then anything after that, so 8, 7, And then how many spots has it moved? 3, 6, 9 times 10 to the power of 9. So what I have done here is converted all these basic numerals or standard form, numbers written in standard form, into scientific notation, or standard notation into scientific notation. And you can see why scientists would use this, okay, instead of writing all the zeros. I don't know about you, but sometimes when I deal with very big numbers, I have to make sure I've written all the zeros. Okay, so doing stuff like this is a lot easier. And also when you're adding or subtracting, multiplying, dividing, it is easier to work in scientific notation. But for the purposes of Year 10 maths, this is all you need to know. And for those of you who are doing sciences, so biology, chemistry and physics, not so much psychology, you probably come across scientific notation as well. All right, so they're very big numbers. Let's have a look now at very small numbers. Now, it took me a while to actually find something that I could use. And these numbers are already written in scientific notation. And they are to the negative, okay? So remember before, let's go back to the planets, we had a positive power. When you have a positive power, you're working to a very big number. Here, when it's negative, it's a very small power. Negative power, it's a very small number. And I'm just going to explain this diagram before I actually get into the math. So this image is basically telling us, well, what can we see with our eye? What can we see with a light microscope? And what can we see with an electron microscope? So obviously you all have seen something, so you've used your eyes before. You've probably also in science looked under a microscope, a light microscope. I'm not too sure whether we have electron microscopes, but basically you can see a lot more in an electron microscope. So if you were to look down at your hand now, and I'm looking at my hand, I can see my fingers, the palm of my hand. I've got a ring on, I've got nails, they're painted, I've got a scratch on my finger. But I could see a lot more if I looked under a light microscope. So if I looked under a light microscope, I could probably see my fingerprints a lot better. I could probably see if I had any dry skin. I can see the hair on my hands, but I'd probably see the hairs a lot easier. My freckles, I've got a lot of freckles. But then if I looked under an electron microscope, it's possible to actually see things like bacteria, dirt or dust or things that are very, very small. These things here, so let's just get my pen. So viruses, okay, your DNA, small molecules. Okay, so these things can all be looked under a microscope. So if you're feeling unwell, your doctor might take a blood sample or a urine sample and actually be able to see whether you have some sort of virus. Okay, so that sort of testing is done with an electron microscope. Okay, now let's have a look at the maths involved. So as I said before, the numbers are all written in scientific notation. Okay, so human, it's got at 1 meter, very short human, but it's basically just showing you the relative sizes. All right, now we're going to look at other items here. So first of all, just the apple, because we all know what an apple looks like and roughly how big an apple is. Okay, so when you're doing maths, you always got to think, well, does my answer make sense? So your apple is 10 to the negative 1 meters. Now, if I was to do that on a calculator, and I'm not going to do it now, but you can do it on the calculator just so you can see whether I am correct. It's 0.1. And 0.1 of a meter is equal to 10 centimeters. Now, I'm just going to think, well, is an apple about 10 centimeters? Well, yeah, it is. It's a big apple, but 10 centimeters still seems like a good answer. Now with this 10 to the negative 1, basically this is written as 1 times 10 to the negative 1. So don't think you move your decimal place with this 10, it's moved with this 1. So if I wrote 1, my decimal is moving just in front of the 1. So that's where the 0.1 comes in. Let's try it with the WASP. Okay, so the WASP, we all know what a WASP looks like, unfortunately. There were a lot of wasps around over the school holidays. I don't know whether it was in Melbourne, where I went away to. Okay, so anyway, the WASP. We know a WASP is a little bit smaller, a lot smaller. So it's got us having 10 to the negative 2 meters. Now remember that's 1 times 10 to the negative 2. And we don't usually write the 1 times, but we need to remember it there when we move our decimal place. Okay, so remember your decimal place is originally here. We move it 1. Now if there's nothing written there, you just got to put in a 0. Okay, so it becomes 0.01. And that is the same as 1 centimetre. So if you think about 1 centimetre, you're like, oh, yeah, that's roughly right. Probably a bit bigger than 1 centimetre. Maybe it's a baby wasp. Maybe it's a certain type of wasp that's only 1 centimetre. But what you need to know is this maths that's involved, how to actually get the number. So let's have a look at the ant now. Okay, so if you want, you can pause it. Okay, I'm going to write ant because I had A for apple before. So the ant is 10 to the negative 3. Okay, so remember that's 1 times 10 to the negative 3. Let's get that negative in. All right, so we've got our 1. Okay, our decimal place was after it, so we move it 1. If there's nothing there, we've got to put a 0. 2, got to put another 0. 3. And always put a 0 at the front. So it's 0.001. A bit of hair. Okay, can you see the pattern? All right, let's do the hair. Perhaps pause it and see if you can do it yourself. Okay, so the hair is 10 to the negative 4. So that's 1 times 10 to the negative 4. So 1, moving it 1, 2, 3, 4. So 0.0001. All right, let's do something. Let's skip a few because we're not going to do them all. All right, let's do a small molecule. Okay, so 10 to the negative 9. Okay, and 10 to the negative 9 is actually 1 nanometer. Okay, so it's very, very, very small. And I've just realized I shouldn't have picked that one because I'm going to have to write a lot of zeros. Okay, so that's 1 times 10 to the negative 9. Okay, so we've got, I'm going to write the 1 over here because I'm going to have to write a lot of zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, let's just make sure I've done that correctly. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and I'm not going to rewrite it, but you can see there. And you can always check your answer by counting. I usually say this tells you how many zeros you need to have. Okay, so if we're doing 1 times 10, not like with the distances where we were dealing with other numbers, but with just 1, you can just move your decimal place 9 spots, or just think, well, I should have 9 zeros there, including the 0 at the front. And you can see that is a very, very small number. And that is why we cannot see small molecules with our eye. We can't even see them with a light microscope. We need them with we need an electron microscope. And the reason why we use scientific notation, not only just so we don't have to rewrite this very, very small, lengthy number, but so we, when we're doing rounding, if we was to say, oh, round this number to 2 decimal places, you're going to get 0. Even if we did it to 5 decimal places, you're going to get 0. So what you need to say is, well, no, it's not 0 because a small molecule actually exists. Okay, it's not 0 because it actually exists. So scientific notation is kind of like rounding, but it's a different way of writing rounding. Okay, so we use scientific notation for very big numbers, as in the planets, and very small numbers, as in, molecules and so forth. Okay, I've just realised the time, and I want to keep my videos under 20 minutes. Okay, so here are some questions for you to have a go at. So I might just, you do have a copy, but you can actually just copy these down if you like. So question 1, we're using scientific notation, and number 2, we're converting them back to their basic numbers. So you can pause now and have a go at doing them. Okay, so I'll go back up. Oh, you can obviously pause. Okay, and then you can play and watch them. Okay, so convert to numbers using scientific notation. So the first one, remember, we always write the first number followed by a decimal place, and then any number after it except for the recurring zeros. Okay, so we've got 6.57. How many spaces has this decimal place moved? So your decimal is here. Okay, we don't usually write it. So it's moved 1, 2, 3, 4, 5, 6, 7. So it's times 10. And it's a very big number, so it's a positive power. Okay, so remember, if it's a big number, positive power, or basically if you've moved your decimal in the I'm just trying to think of an easy way. But yeah, I think just if really big numbers, positive power. All right, the next one here, remember we do include that second 0, so 9.01 times 10. How many spots have we moved it? 1, 2, 3, 4, 5. Next one, okay, so we've got a really small number now. So it's 1.92. How many spots have we moved it? 1, 2, 3, 4, 5. So times 10 to the negative 5. Oh, what I was saying before was, I just realised now it does work. You're moving your decimal in the positive direction, positive power, moving it in the negative direction, negative power. All right, this one here, 4.2 times 10. Okay, what do we got? 1, 2, 3, 4, 5, 6, 7 times 10 to the negative 7, because it's a very large number. All right, now let's move to question 2. Okay, so this time, this is what we did before. So 4.55. What I need to do is just write the numbers. Don't worry about your decimal place yet. Okay, because I can write it on here. So we're moving it -4. So that means that it's going to be a very small number. So I've got to move it into this direction. Okay, so that's 1, 2, 3. Hold on. 1, 2, 3, 4. Okay, so I've got to put 3 zeros. Didn't leave myself much space today. And your decimal. Now, if you're ever unsure, you can actually just type this straight into your calculator, and you should get, obviously, this answer. If it's not giving you a decimal answer or the basic numeral, you can see me and I'll just show you how to change the settings on your calculator. All right, the next one is a very large number, so I'm going to write 6 and 2 without any decimals, and the decimal has moved 3 spots. So 1, 2, 3. So I'm just cheating here. Okay, so 1, 2, 3. So 6,200. All right, this one, 2, 4, 5, 1. Okay, so it's moving 1, 2, 3, and then another 3 zeros. And then the last one, a small number. So, oops, didn't need to put that decimal there. 1, 9. Okay, so we're moving at 1. So I think 4 zeros. 1, 2, 3, 4, 5. Yeah. Okay. So that's scientific notation. If you're going into, it's more for the science subjects or specialist mathematics, but also you need this basic understanding. You know, when you do come across numbers in further maths and maths methods, or in general, basically, you need to be able to interpret what it actually means.